welcome to Khetztutorials, and in this video I'll be doing examples for the section which I've been doing, functions, and we have quite a few functions here, different types of functions, the ones which are actually covered, and I just basically want to show you some of the questions which you may encounter when working with functions. Obviously, I can't do all types of questions, but I hope the stuff which I'll actually do will help you to work your way through whatever problem you may have. And so let's start. We're going to work with each one, so one at a time. Basically, going to work with similar questions, but we're going to work with one problem at a time, or one type of function at a time. So let's start with this one, which I labeled as 1. So the first question would be to identify the functions. What type of function do we have here? So if you look at the first one, what type of function do you think we have? So to identify that, you try and go back to the forms which I previously discussed in all of the videos. So different functions have different forms, or different types of functions have different forms. And if you look at this, you'll see that it is quite similar to y equals to ax squared plus bx plus c. And your a coefficient in this case would be -1, so that's -1, and your b would be 0 because there isn't any x in here, which means the b was 0, and your c is 4. Now, from all of this information, and after identifying this, we can see that this is a parabola, right? So we've identified the type of function that we have, and the next question, or another question, would be to actually, so we're going to look at that in a bit. Let's just work in sequence with the questions which I have over here. Okay, so the next question would be the next thing would be to sketch this graph. So given this formula, 4 subtract y is equals to 4 minus x squared, how would you actually sketch this? So that is the question. So since we've correctly identified the form and we know how to deal with each form, you'll see that a here is negative. So a is -1, so it's negative, which means our graph is frowning, or it points downwards. From our previous discussion of parabolas, if you haven't looked at that, just quickly go to that. I made a video on that. So our a is negative, and we expect our graph to be pointing down, or to form some sort of frowny face like that. So that is the first thing which we can conclude. And our c is equals to 4. And this c corresponds with our shift, like our horizontal shift, vertical shift that is, because we are talking about the y when we come to this c. And actually it corresponds with the y-intercept of the graph. So we know for sure that our graph has a point 0, 4, and since there isn't any b, that is basically all the information which we can need at this point. We know that it's pointing down, and its y-intercept is 4 from the equation, and therefore it's going to look something like this. Now, if you were asked to specify this a bit further, you'd have to find your x-intercept, and to do that, it's quite simple. To find your x-intercept, you say, so finding your y-intercept, you can just do, instead of just looking at c, you can actually calculate your y-intercept by saying x equals to 0. So when you put x equals to 0 here, you'd see that y is equals to 4, which confirms that our y-intercept is actually 4. Now we're going to find the x-intercepts for our x-intercept. Then your y is equals to 0, which means you'll have 0 is equals to 4 subtract x squared, and therefore x squared would be equals to 4. Now the answer to that is x equals to plus or minus 2, which means our x-intercepts for this graph are minus 2 and 2. So we have minus 2 over there and we have 2 over there. And the coordinates for that would be 2, 0 and minus 2, 0. That basically completes our sketch. A sketch is just a rough drawing and is not drawn to scale. Just the basic things have to appear on your graph, the intercepts, and an indication of whether the function is pointing upwards or downwards when it's a parabola. And we'll see how we can apply all of the forms in the other types of equations which we have. So another question which you can be asked is if a certain point occurs on this graph. So let's say if they ask you is this, let's say we have an x and a y on the graph. Excuse me. So to actually see if a certain point is on the graph, you'd just substitute either the x or the y value of that thing. So if you want to check if 0, 4 is on the graph, so we know that 0, 4 is actually on the graph because it's the y-intercept of the graph. But if you want to make sure that it is on the graph indeed, then we actually substitute either the x or the y into the equation and see if we can get the other value. So we're going to substitute x equals to 0. So substituting x equals to 0 into our first equation is going to give us y is equals to 4, which is indeed the y value which is given to us. So if your x value, the substitution of your x value gives you the y value, or the substitution of the y value gives you the x value, then you know that for sure you have that point on the graph. So that's another variation, or that's another type of question you can actually be asked. And we wouldn't really have defined our graph if we didn't touch up on the domain and the range of the graph, right? So let's look at that quickly. So we previously defined or previously talked about the domain and the range in the previous video where I specifically talked about parabolas. Now, if you look at this graph over here, the domain is a description of the x values which it covers. And if you want to find the domain of this, we actually look at, so what can we look at? You can look at the graph itself and actually see what x values it covers. So if you come to the graph, you'll see that the arrows go all the way in that direction up to negative infinity, and on this side it goes all the way in that direction to positive infinity, right? So in this case, we can conclude, because these are arrows which show that this graph actually goes on and on forever in either direction, so we can conclude that the domain is x element of negative infinity to infinity. So this x basically covers all real numbers. So it covers all of them because there isn't any point where you can't find this graph in terms of x. Now moving on to the domain, or the range, sorry, we've already covered the domain. Now looking at the range is a description of the y values which the graph covers, and you'll see that the y values which this graph covers are from this point at 4 downwards, right? So the maximum value is 4. So that's another question. If you're asked to find the minimum or the maximum of this, the maximum will be 4, right? And you can use that to your advantage to find the range, and your range would therefore be all the values from negative infinity to the point 4, and 4 is included. That's why we have the square brackets. It's included in your range, or it's included in the function itself, and that is why you basically have that value, right? Now that we have that, or just before we proceed, here's another thing which you can use along with this type of formula. If you're asked to find the turning point, so TP, which is the turning point, or just to confirm if that is indeed the turning point. So I just quickly concluded that that was the turning point, but the y-intercept isn't always the turning point. So we have to fix that. To make sure that you actually know your turning point, you can just say x is equals to negative b divided by 2a, and your b is 0, so x therefore b equals to 0. So you know that your turning point is found at x equals to 0, and now if you substitute x equals to 0 in here, you have y equals to 4, and therefore your turning point is indeed this point that we have with us over here. You shouldn't immediately conclude that your y-intercept is your turning point. So please make sure, if you have this type of equation, please make sure, if you have this type of equation, just make sure that you actually do this substitution so that you can actually have the x value, the correct x value for your substitution to find the turning point. So if the question said you had to find the turning point of this graph, then your turning point TP would be 0, 4. Now this range can also be, this is basically how you denote the range. It's from negative infinity to 4 included, right? So we've covered the type of graph or the type of function. It's a parabola. We found the turning point. We found the intercepts, both the y and the x-intercepts. We found the domain and the range of the function. And we correctly identified that it points downwards. It's a decreasing function. But you can also be asked, for what values is this graph increasing? So it's not decreasing everywhere, because if you check the y values, let's look at the y values from this point, negative infinity, to the turning point. They're actually going up. If you go from negative infinity to 4, you're actually increasing your values. So from negative infinity to 4, the graph is actually increasing. But from this point, you have a y value of 4, and you continue to decrease towards the y value negative infinity again. So it is possible that for a function, you have parts where it's increasing and where it's decreasing. So they can ask you that kind of thing. So for which part or for which x values is the function increasing? So you just look at the part where the graph has increasing y values. And for this graph, it's from negative infinity to the point. So negative infinity to the point 0 in terms of x values. So what else can we look at? Okay. So that is basically it for this specific question, or for the first graph. We can now move on to the other one. The other questions will follow after we have everything figured out. So we can essentially just erase some of it, so we create some space for this next part. All right, let's proceed. Now proceeding to this one, we're going to do the same thing as we did in the previous one. Let's identify what type of function it is. So this is quite similar, or it resembles something which we looked at, which is y equals to 1 divided by x subtract p plus q. Now, if you look at this, what type of function is it? Or what would you say it is? So this is basically a hyperbola. And you'll notice that it has p and q, which kind of tells us that it has two asymptotes, as previously discussed in the video. Once again, I'll just put the links to all those videos in the description in case you haven't seen that. So it has two asymptotes, we know that for sure. So let's first deal with that. So the first asymptote, you take this bottom part here, which you have. So q is equals to 0 because it's not in the equation. You just have 1 divided by x subtract 4, so q is equals to 0, which means our asymptote is this q equals to 0 is equals to this x-axis. So y is only 0 along the x-axis, which means the x-axis is one of our asymptotes. It is the horizontal asymptote that we have. And the other asymptote that we have is x subtract 4 equals to 0, so x equals to 4. That's another asymptote that we have. So the other asymptote occurs somewhere there, and it's equals to 4. That is our vertical asymptote. So these are our two asymptotes that we have. And what other things can we look at from this graph? So another thing is that our A, so you basically don't have 1 at the top here. For your general form, you have A at the top of here. Excuse me for that. Let me just erase and write it properly. So you have the general form is A divided by x subtract p, and your A actually indicates where you expect to find your graphs for a hyperbola, right? So A in our case is greater than 0 because A is equals to 1, right? And that tells us that our graph should actually occur in the first and third quadrants, right? So you can just do a rough sketch and make the graph approach the asymptotes, but the graph shouldn't touch the asymptotes because that's what asymptotes are. The graph approaches but never touches. So that is our sketch, but there are quite a few details which are still missing from this. And one of those details are the intercepts. So what intercepts does this have? So obviously it won't have any x-intercepts because the x-axis, the whole of the x-axis is our asymptote. So no x-intercept. So we expect to have y-intercept. So for y-intercept, you basically do the same thing across all graphs or all types of functions. So for y-intercept, you have x equals to 0. Now substituting x equals to 0 into this given formula over here, you're gonna have y equals to negative 1 over 4. And that is gonna be your value for your y-intercepts. Over here, it cuts at negative 1 over 4. So that point over there is negative 1 over 4. The coordinate of that would be 0, negative 1 over 4. So that is that. What else can we use to define this function? So we can move on to things like the domain and the range of the function. So let's cover that quickly. Looking at the domain again is a description of the x values which are covered by the graph. And if you look at this, it goes all the way up to positive infinity in terms of x, and it goes all the way to negative infinity in terms of x, but it does not include this value, which is 4, because that part corresponds with its vertical asymptote, and therefore we can say that the domain of this is x consists of all values, but x is not equals to 4, which is the same as x is an element of negative infinity to infinity, but x is not equals to 4. Now looking at the range, let's move on to the range. So the range is the description of the y values. Let's look at what we have. So once again, for this graph, we have all the y values up to infinity and all the y values up to negative infinity. So it basically covers everything, but if you look at this graph, it doesn't cut the x-axis or it doesn't touch the point where y is equals to 0, which means we can say that the range is x consists of all values. So this is y, we're talking about the range now, so it has to be y. So y consists of all values, but y is not equals to 0. So y is an element of all values, but y not equals to 0. So those are the domains and ranges for this particular function that we have, this particular hyperbola that we have. And we've basically covered similar things as we did in the previous one. We've covered the intercepts, we've covered a new thing which we found and which is specific to this. We've covered asymptotes, and we've also covered the domain and the range, which are basic descriptions of functions. So that is how you deal with parabolas and hyperbolas. We now move on to another function which we have over here. So this is y equals to, let me just write this properly, y equals to 4 subtract x. Now this resembles something which is quite familiar to us. It's y equals to mx plus c. So even if you don't really cover straight lines in grade 12, please don't forget this, because it's quite useful. It's useful everywhere. So this is a straight line graph. So this is a straight line. It's a straight line. That is what we have. And there are certain things which we should look out for to describe this, or to actually successfully sketch this. And the first thing is m, which corresponds to the gradient. So m is equal to -1. It's over there. And our c is equal to 4, and this c is the y-intercept. And we don't know what this what's this. We don't know the x-intercept as yet. So let's just use the information that we have, and we're going to proceed accordingly. So m is equal to -1, so m less than 0. So m less than 0, you have a decreasing line graph. So an increasing one looks something like this, and a decreasing one looks something like this. So basically, as you go along, or as x grows, so as you add x values, your y value decreases. That's how you identify a decreasing straight line graph. So as we increase our x values, the y value decreases. And that is what we basically have in our case. And we're going to draw that straight line. This is just a sketch. We don't know all of the information yet. What we basically know from the equation is that the y-intercept is 4. So we have 0, 4 over there. Now we can find our x-intercept. So x-intercept, we just equate or say y is equal to 0 for x-intercepts, and x is equal to 0 for y-intercepts. You can also find the y-intercept by substituting 0 into this equation. You should get the same value of 4, or just look at the equation itself, right? So for our x-intercept, we're going to say y equals to 0. So we're going to have 0 is equal to 4 subtract x, and therefore x is equal to 4. So basically just have the same thing as your y-intercept. So you have 4, 0. So that is the sketch of our straight line graph, and we can now further describe it using the domain and the range. Another thing you can identify is that the c actually dictates the shift, whether you go up or down. So if you were to look at something like, so these are some things which I expect you to know. So if you were to look at something like y equals to x, it cuts at that point. And this is y equals to negative x. Sorry. Y equals to negative x. So if you take y equals to negative x and you shift it by 4 units upwards, you actually get this one here, which is our equation in the question. So just saying y equals to negative x and adding 4 to that shifts the graph upwards. So you can just use that information to actually help you to draw these straight line graphs or any other graph. So if you know a basic graph for, like, we can come back to this one and apply the same principle. So if you know a basic graph like y equals to negative x squared, which should be somewhere there. So y equals, you know that y equals to negative x squared looks like the yellow graph which I drew. And now you have y equals to negative x squared plus 4, which gives you this equation. Now to move from this to that, you basically just shift this graph upwards, and that will help you to actually sketch these things faster. So if you know the basic graphs, or if you know the basic ones, you can know how to shift all of these values. And that is just a useful tip which I had for you guys, to know that you can actually shift basic graphs depending on the values you have in your equation. So this is a shift from negative x to negative x plus 4, just a vertical shift by 4 units upwards. So now let's move on to the domain and the range. So the domain and range. So the domain of this is a description of, once again, the description of the x values. And as you can see, the green graph is not restricted by anything, and therefore covers the whole range of the x-axis, which is all the values from -infinity to infinity. Because if you look, it covers all the values. If you go in either direction, if you go in that direction, this arrow carries on to -infinity. If you go in that direction, it carries on to +infinity. And therefore, we can conclude that our domain is actually x is an element of -infinity to infinity, which can also be denoted as x is an element of all real numbers. So now we can say that is the range, and we can move on to find, that is the domain, and we can move on to find the range. So if we look at the range is pretty much the same. There are no asymptotes linked to straight line graphs, and therefore you can say, or you can see that the graph proceeds in that direction up to infinity, proceeds in that direction up to -infinity with no restrictions, and therefore the range would be the same as the domain, and it would be y is an element of -infinity to +infinity, and this can also be denoted as that. So you'll see that I'm actually writing the two forms that you can denote this as. You don't have to put both of these when you answer questions in your tests. Just put one of them, or the one which actually makes sense to you. Yeah, basically that. Or if they specify the type, I don't think they'll specify, but if they specify how you should denote the domain and the range, just please follow that. But if they don't, just follow the type of notation which will lead to less mistakes, or the one which you understand best, right? So now let's proceed to the final question which I have in terms of examples, and then I'm going to discuss a few more things, so we won't be exactly done after doing this question. I'll still have a few more questions, and then we'll close this video because it's getting quite long. So y is equals to 4 to the power x, right? So this is quite simple. We have a power. We have something which looks like y equals to a, b to the x, y a b to the x, subtract p plus q. So from the get-go, you'll see that p is equals to 0 and q is equals to 0. And this is an exponential graph, so you can identify that to be an exponential graph. If you ask what type of graph it is, it's an exponential graph. You see that from having a variable as your exponent, and that would be your exponential graph. Now, in terms of the asymptote, you have q equals to 0, and you have your p equals to 0. So the asymptote for an exponential graph, it only has one asymptote. Please don't forget that. It only has one asymptote, and that is your horizontal asymptote, which is determined by q. And p only dictates the shift of your graph, either to the left or to the right. And so our asymptote in this case is y equals to 0 or q equals to 0. And that is in relation with the x-axis. So our asymptote is the whole x-axis. So we expect our graph to actually approach but not touch the x-axis. So now let's look at some other things which are going to help us to sketch this graph. So a is equals to 1, right? A equals to 1. So a is greater than 0, and b is greater than 1 because b is equals to 4. So this information is going to help us to determine two things. So a will help us to determine whether the graph occurs above or below the asymptote. So now that we have an a which is greater than 0, then our graph will be above the asymptote. And once we have identified that it will be above or a greater than 0, we apply this specific rule here. Since our b is greater than 1, then we have an increasing function, right? So increasing, just take that as increasing. You can just write something like this. So we know that the graph is going to appear somewhere here at the top, right? And since this is our asymptote, the x-axis is our asymptote, so it's going to appear somewhere here at the top because a is greater than 0. And the graph is actually increasing, which means as we increase our x values, the y values of the graph should increase. So the correct way of drawing such a graph would be something like this. So let me draw it closer to the asymptote because it approaches the asymptote, but it doesn't touch the asymptote, right? So a graph will look something like this. And this is the asymptote, the whole x-axis is our asymptote. And we are going to proceed to say that the y-intercept is found when we have x equals to 0. And x equals to 0 in this case gives us y equals to 1. And your x-intercept is non-existent. It's non-existent because the whole x-axis is our asymptote. So you don't have any x-intercept. So you can put it as in, yeah, that's that. We don't have an x-intercept because it doesn't cut the x-axis. So this point over here, we just found it to be 0, 1. That is our x-intercept because this is the y-axis. And that is our basic sketch of our graph. We can further describe this like we did previously using the domain and the range. And the domain here, we'll have the domain as the description of all the x values. If you look at this graph, it actually covers everything from negative infinity to positive infinity. It just keeps going on and on. And therefore, expect your domain to be, so expect our domain to be x is an element of negative infinity to positive infinity, which can also be denoted as that. Moving on to the range, let's look at the range. So our range is gonna be, let's come back to the graph so that we can look at what the range is or how it looks like. So this graph does not pass the x-axis. There are no values for this graph below the x-axis. It only occurs above the x-axis, and the x-axis has a y value of y equals to 0. And so we can conclude, and it doesn't actually touch the x-axis because that is at the asymptote. So we can conclude that this goes on and on from 0 to infinity. So a representation of that would be our domain, and that domain would actually be y is an element of 0 to infinity, or y greater than 0. Now here we have a round bracket because we cannot include the coordinate or the value of our asymptote. So 0, y equals to 0 is where our asymptote is, and we therefore cannot include that. So please take note and please use the brackets correctly. When you have your round brackets, you don't include the value. If you have your square brackets, you actually include the value. And as you can see, wherever you have negative infinity and positive infinity, I did not include the square brackets because you cannot include infinity. We don't quite know what infinity is, and therefore you can't include that in your range or domain. So we've covered quite a few things, and some other things which you have to know or which you have to look at are the following. So please look at, so this is some sort of homework. Please look at reflections and different types of translations. We've actually started looking at translations when I talked about the shift when we add 4, right? So I've actually started talking about translations, but look at reflections. If you look at, for example, y equals to x squared, which looks something like this. This is your y equals to x squared. And you look at y equals to negative x squared. This is y equals to negative x squared. Now, if you look at these two graphs, you'll see that they're actual reflections or mirror images. So a reflection is a mirror image. It's a mirror image. But it has to be defined along a certain axis. So this is defined, so this is a reflection about the x-axis. And therefore, to find the reflection of that, you just basically negate your y values or your graph. You just say, so to find the reflection, about x, you just say the new equation. So let's just say the new equation would be, so y2, which is the new equation formed by the reflection, is equals to negative of the original one. So if you say the negative of the original one, in our case, y2 will be equals to negative of x squared, which is our y. Y is equals to x squared. And if we negate that, we get negative x squared. But if our original value or original equation were negative x squared and we're asked to reflect that about the x-axis, we basically do the same and negate that value. And the reflection of that about the x-axis would be y2 equals to x squared. So to find the reflection about the x-axis, you just basically negate your equation. So just introduce a negative to everything which you find in your equation, right? However long it is, just negate everything and you'll find your reflection about. So that is just an example, and you can look at further things like reflection about the y-axis and stuff like that. And I also haven't really covered much about inverses and stuff like that. So just go back to my video about inverses and use that information to do whatever problems you want to do. And another thing which you must know is, so I have two more things which I want to discuss. So these are the last two things which I'm going to discuss. So let's say you have, let me try to be neat and actually have neat axes. So let's say you have a graph which looks like this, and another one which looks, let's say, like this. And you have points, this point, let's call it, okay, so you have points, let's call this point, let me actually redraw this so it actually makes sense according to the coordinates that I have. Let's say you have something like that, okay, and you have these 2 points. You have A, the first point of intersection, which can be said to be 2, 1, and you have the second point of intersection B, which can be said to be 4, 2, right? Not drawn to scale. I just want to show you something. So let's say you have these 2 graphs, the black one and the red one, and you are asked the following questions. For what values of x is f of x less than p of x? So let's name these. So f of x would be the black one, so this is f of x, and the red one would be p of x. So the question comes to you, it says, for what x values is, so for what x values is f of x less than p of x? So how would you actually answer that? So this question is actually asking you where, if you were to look at the graph, it's asking you where is the graph f of x below p of x. So there are 2 regions which you can actually identify. If you come here, you see that your f of x is below the red graph over here. It's also below the red graph going on and on, because this will just increase in that direction, this will go in that direction, but it will never be above this one. And therefore, for this whole region here, it's also below. But here, if you look at this point here, your f of x is actually above the red graph, and therefore we can't include that. So your answer to this question, it says, for what x values is f of x less than p of x? So you look at the points where your f of x is below, which are the green points which are highlighted, and those points are quite simple. You can look at 2 points where you have the values from, if you look at this point over here, so it's going to be from, let's take the top part, which is going to be from 4, right, to infinity, or you can take the other part, which is basically from negative infinity to true, right? So it's asking for what values of x will f of x be less than p of x. You just look at the points where your f of x occurs below your p of x. And if it asks you for the values of x where f of x is greater than p of x, you just basically look at the opposite. You just look at where your x value, or where your graph f of x occurs above this graph, and that would be between 2. So I can just denote this as between 2 and 4, or x is an element of from 2 to 4, right? So that's how you denote that, and that is basically how you answer those type of questions. You just look at where your graph is actually below or above, depending on whether you're asked if it's greater or less than. And another question, or another type of question which I want to look at in closing, is if you are given something like g of x is equals to negative x subtract 1 squared plus, let's say, what can we say? Let's use a value of 2, right? Plus 2. And you're told that your h of x is equals to g of x plus 1 subtract 2. Then what would be your h of x? So let's say a question says, write the expression for h of x if h of x is equals to g of x plus 1 subtract 2. So this is quite simple. What you basically do is you just substitute x plus 1 wherever you see x in your original g of x, and you therefore do something like this. And here where we see our first x, just substitute x plus 1. And so everywhere where you see x, if you're given something like this, everywhere where you see x, just substitute whatever is in here. So your h of x will therefore be equals to negative. So inside here you have x plus 1 subtract 1 squared plus 2. You have h of x equals to the negative. This will cancel out, so we have negative x squared plus 2. Not forgetting this minus 2 on the outside, so you have that as well, minus 2 minus 2. And the final value, or the final answer, will be h of x is equals to negative x squared. And that'll be your answer. I've covered quite a few things: domain, range, intercepts, how to identify a graph, how to deal with each types of graphs, which I previously talked about, how to find asymptotes, how to do translations, how to do reflections, and how to do these substitutions, how to identify where a graph is increasing, and how to see where a graph is above or below the other graph, as well as how to do these basic substitutions. I've already said that. So if you really like this video, or if you found it helpful, please give it a thumbs up. And if there are any questions, or if there's anything which was unclear, please let me know. Please let me know. Now for this question, if you are to actually look at it, you have to define, let's come back to this thing before I close. You actually have to check where your graph is defined. Let's say this graph, the black graph, which is f of x, was only defined for x greater than 0. Let's say the y-intercept was the asymptote, which kind of looks like the case here. So it never actually touches here, or it never actually goes into the negative values of x. So the answer to this, where f of x is less than that, would change to from 0 to 2. If we knew for sure that this y-axis was the asymptote. So you always write your values for where the graph is actually defined. So this graph, if we are told that this y-axis is the asymptote, it would not be defined for some place like negative infinity. And that is why we can change that answer to from 0 to 2. So that is that. And that is all I had in this video. If you haven't subscribed, please subscribe. And once again, if you like this video, just go ahead and give it a thumbs up. And I will see you guys in the next video. Thank you.